Welcome back to the channel. Today we are diving into a really important topic in Kubernetes, workload and scheduling, with a focus on robust and self-healing deployments. If you are preparing for CK exam or just want to understand how Kubernetes keeps your application running even when things fail, this video is for you. Let's break it down slide by slide. Here we are looking at one of the key domain of CK certification, domain 3, robust and self-healing deployment. This section is all about making sure your applications stay online no matter what happens, like node crashes, pod failures, container restart. Kubernetes has your back. And the best part is many of these features are built in and automated. You just need to know how to configure them properly. On this slide, we see the major concept we'll cover under the domain. The first one is deployment rollout, which is how Kubernetes gradually introduces new versions of your application. Then is configuration map and secrets, which separate configuration from the code securely. Then workload autoscaling, so your application can grow and shrink based on the demand. Robust and self-healing deployment, the magic that keeps your app running through failures. Pod admission and scheduling, which is how Kubernetes decide where pods should run. In this video, we will zoom in on the robust and self-healing deployment part. Okay, here's the heart of it. Let's break down each point. Application must stay available even if nodes, pods, or containers crashes. Kubernetes gives us automatic recovery. Think of it like having a team of mechanics constantly fixing your cars while you are driving, so you never stop moving. Now the ReplicaSets and deployment, they ensure that desired number of pods is always running. If you say you want 3 pods, Kubernetes watches like a hawk. If one dies, it immediately spins up a replacement. Liveness prop. These are like health checks for the container. If the app becomes unresponsive, Kubernetes kills it and starts a fresh one. Readiness prop. These are a bit different. They don't kill the pod. Instead, they remove it from receiving the traffic until it's healthy again. This way, only ready pods serve the request. Then we have rolling update and rollbacks. Imagine upgrading your application with zero downtime. Kubernetes replaces old pods with the new one gradually. And if something goes wrong, you can always roll back instantly. Now, Kubernetes controllers, these are the brain behind everything. They constantly compare the desired state with the actual state of the cluster. If something drifts, the controller corrects it automatically. This is why Kubernetes is called self-healing. It's like having a doctor on call 24/7 for your application. Now let's see the diagram. We have the liveness prop. We are observing the HTTP GET request, and we are checking the path like after waiting for 5 seconds, it check the path /health on port 8080 every 5 seconds. If the container doesn't respond properly, it restarted. Then we have the readiness pod. This removes the pod from service endpoints until it responds correctly. That means user won't hit a pod that isn't ready yet. Together, these props are the secret sauce for self-healing. Now, there is another YAML snippet as well, which is --replicas 3. This simply means that keeping 3 pods running all the time. If one fails, Kubernetes will recreate it instantly. This is basic redundancy, just like having multiple backup players in a sports team. If one gets injured, another steps in immediately. Now coming towards the live demo. First of all, seeing whether we have already some deployments in the default namespace or not. Now we create a deployment with the name Nginx and the image Nginx, and we configure the replicas as 3. Now exposing this deployment at port 80, that is creating a service. for this deployment. Now, as we can see that 3 pods are readily available. If we delete one of the pod, and let's see what happens. Now a pod has been deleted. Let's see that whether our minus replicas 3 work or not. As you can see that 3 pods are already available. So if one gets down, the other one is pinned up again. Now configuring the props. First of all, the liveness prop. In the liveness prop, we are configuring it on the HTTP GET request. And the path we are giving is /health. It means that Kubernetes will check this path, like our application, for example, HTTP nginx/health. This URL will be checked after every 5 seconds or the time that we define. And if this path is not available, the liveness probe will fail. Now in this example, we have configured the port 80, then we have configured the period second as 5. It means that the Kubernetes will first wait for 5 seconds and then start checking this URL. Now moving forward to the readiness prop. In readiness prop, we are also checking the HTTP GET. It depends. Like we are checking the web application. That's why we are checking the HTTP GET request. If you are checking a TCP connection, you can use the socket. And for execution, you can also check a command, the presence of a directory or something, a presence of a file. So it depends upon the application that you are checking. In this particular example, it is a web application, so we are using HTTP GET request for the props. Now the readiness prop is checking the /ready URL. That is like HTTP nginx/ready. This URL will be checked after every 5 seconds. And if this URL is not available, the readiness prop will fail. Now, after configuration, we will watch the pod, that whether we are getting the pod status or not. As you can see, like I configured a basic nginx web server. I didn't configure the /health path, and I didn't configure the /ready path. So the first one, let's consider the first one, the /healthz, which is the liveness probe. It is failing because the particular URL is not available to the Kubernetes, and it is not accessing this URL. So after some time, it start restarting the pod so that the pod become active. As you can see in the status, you can see the restart counts as well. There is a restart count of 3. And after this, it shows that crash loopback, that this pod is not available, and this pod is not getting up or becoming active. Now we give the path of /. And let's change the wait time and reduces the wait time so that we can observe the changes more quickly. Now again checking the kubectl get pods. Now as you see that the pod is not restarting because the liveness probe is now active, but the pod is not becoming ready. It is because now the readiness probe is failing because we haven't configured the /ready URL. Now let's make changes in the deployment configuration and change the path to /. instead of /ready. Now saving the configuration. Now if we see the, yes, you can see that now the pod is running and it is ready as well, because both the liveness probe and the readiness probe are successful. And that's the end of our slide. We have covered today how Kubernetes ensures your application are always available, the role of replica set deployment, liveness and readiness probes, how rolling updates and rollbacks save you from the downtime, and why Kubernetes is called a self-healing system. If you found this useful, hit the like button, share it with your friends preparing for CK, and don't forget to subscribe for more deep dive Kubernetes content. Thanks for watching, and remember, with Kubernetes, your application don't just run, they heal themselves. Thank you very much.